and then they start repelling each other. So from the end view, it looks like this: a wire this way and a wire this way. Would they repel each other? Let's see. I always forget too. So I have to kind of remind myself, oh, okay, same charges repel. So then I have to say, unlike currents repel. Yeah. Because unlike charges attract, right? So unlike charges attract. So unlike currents repel. Okay, so these guys are going to repel each other. So what is this angle then? Remember the pith ball problem? So then this will be very similar to that. We can say, okay, this is 80 centimeters. And then I have to give a length to each one. Let's say each wire is the same length, of course. Let's say 40 centimeters. It could be rods too. They don't necessarily have to be wires. Rods, 40 centimeters. Okay, and then we have to give it some mass. Mass, let's say 100 grams each. Okay. Wow, it's going to be very similar, but of course the equation is different, right? So then you have tension T. Just take one of them and analyze the forces on it. So tension T, F, and then theta is this. And then mg, right? T sine theta is equal to F, and then T cosine theta is equal to mg. I usually put the sine on top, and I put the cosine on the bottom, and because I know I want to divide them out and get tangent theta. Right? So tangent theta is F over mg, and then the F, I'm going to put that equation. mu0, I1, I2, L over 2 pi r. So tangent theta is mu0, I1, I2, L over 2 pi r. So that's all that is the F. And then you have the mg. So I have to give you the current of each one. The currents don't necessarily have to be the same magnitude, but the masses should be the same to make them go out to the same angle. The mass has to be the same, but the current does not. So the current can be 1.2 amps. The other current can be 1.8 amps. So then you have 4 pi times 10 to the minus 7. 4 pi times 10 to the minus 7. Of course, those cancel. So then you get here 2 times 10 to the minus 7, right? Okay, then you have the currents. 1.2, 1.8, length, 0.4 meters. The pen is tired. It's like it's on its last wind. Divided by r is the distance between them. Oh, which is going to be what? This distance is 80 sine of theta, right? 80 sine of theta. And then so the total distance is going to be 160 sine theta. And then you change that to meters, 1.6 sine theta. So the difference is that with this force, it's not r squared, right? With the Coulomb's law, it was r squared. So we have, let's see, r is going to be 1.6 sine theta. And then m is going to be 0.1, and then 9.8. Oof. Come on, right. Okay, then, the sine of theta can go there, right? And then there's no easy way to simplify that. Sine tangent, you can just keep it as sine tangent. Okay, then let's just calculate this. Ten to the minus 7. So you have sine of theta, tangent of theta is 1.102 times 10 to the minus 7. Oh, it's such a small number. Let's see what that comes out. Sine squared over cosine. Oop. What happened? Point 0.00033. Oh yeah, because it's such a small number. 0.000. What was it? 0.000332824. 332824. Yeah, that's the number. That's probably radians, right? I think that is radians. Yeah, it should be radians. So in degrees, what would that be? Maybe a little bit bigger in degrees, right? So it came out 0.0002824 rads. So then you say pi rads is 180 degrees. So 0.000 332824 divided by pi times 180. Okay, we'll get slightly bigger angle. 0.019 degrees. So barely noticeable. Slightly goes up. 0.019 degrees. In order to make it a lot bigger angle, what do we need to do? Wow, do we need to make the currents bigger? Let's see here. We need to make the currents bigger. Maybe make the lengths of the wire no, you know what? If we make the lengths of the wire, if we change it at all, we're going to increase this, but we're also going to increase this, the distance between them. I don't think changing the length changes anything. If we make it longer, we make this longer. Oh, no, hold on. This length and that length isn't the same at all. No, this is the length coming out this way. Oh, okay. So that's this length, and this is the length of the string. Yeah, we have to make this guy bigger, right? But then if we make this guy bigger, if we made the lengths of the wire of the rods bigger, they're gonna weigh more. You know, I don't think that's gonna help. If you increase this, they weigh more. Yeah, so unless you make this bigger, use another material, and they weigh much less. Yeah, because of this, the mu zero, the effect is not as noticeable as with the electricity, right? Okay, guys. A lot of good topics. On Monday, we will start Faraday's law. And Faraday's law will be the opposite effect of the modified Amperian law. We're going to change the magnetic field and we're going to create electric field. You see, opposite of the law we learned today. For today, we learned changing the electric field, you can create magnetic field. But the opposite is even more amazing. You change magnetic field and you create electric field. There's so many applications of that.